Now, when you start your chart work, you see the charts which are there in the MMD. They are used by the candidates batch after batch. So you may have some old lines or markings on the chart. Uh, you should erase first of all before starting any work on the chart. You should check if there are any lines or markings, and you should erase all these lines and markings, because once you have made your plots, these unnecessary lines or markings could make your plot confusing and difficult for the examiner to understand. So erase all the old lines from the chart before starting the work, including all markings. There may be markings along the latitude and longitude scales. There may be markings along the compass roses. So erase everything. We use a 2B pencil for chart work that gives us the required darkness, as well as it is soft, so it does not damage the chart. Use good quality tools. Use a good quality eraser. The tools which you are using, which could be parallel rulers or set squares, sliding rollers, any other tool which you are using, prefer or recommended to use transparent tools. The transparent tools allow you to see what is behind the parallel ruler or sliding roller or set square. It does not hide any markings. So opaque tools obscure the information, and it may be a difference between doing a question right or wrong. And during a MMD paper, time is of paramount importance. So if you are not able to see clearly the information on the chart because of the opaque tools, that may lead to some errors creeping in your calculations. Now, to increase the accuracy of your plots, we can follow some of these instructions. It is recommended to measure all the bearings and courses by using the nearest compass rose. Avoid using the angle markings on the parallel ruler.
Now, beta, any doubts up to here?
No,
No,
sir.
sir.
Well understood.
Okay, great.
Thank you.
Though these angle markings are provided, they are given there. But as far as accuracy is concerned, the accuracy of these angle markings is much, much lesser. So at least for exam purpose, we should rely on using the compass rose, not these markings on the parallel ruler or set squares. Even when you are transferring the courses or bearing lines from the compass rose, or you are drawing parallel lines, if it is possible, prefer using the same edge of the parallel ruler, because using different edge also could bring in some amount of error in your plots. Now, when you are plotting a certain point on the chart, or you are measuring the latitude and longitude of a certain position, it is always better to use the nearest parallel of latitude and the nearest meridian, or if you are measuring a course or a bearing, it is recommended to use the compass rose with the help of the parallel ruler. Avoid using a compass or divider for these purposes.
Any doubts up to here, beta?
ये सेम
सर
एज ऑफ द रूलर बताना सर.
Ask again, beta.
सर ये यूजिंग द सेम एज ऑफ द पैरेलल रूलर मतलब ये
ओके बेटा, बेटा मान लो कोई लाइन है हमारे चार्ट पे, आपने उससे पैरेलल एक दूसरी लाइन खींचनी है, तो हम पैरेलल रूलर को यूज़ करते हैं, करेक्ट?
यस सर
नाउ यू हैव द ऑप्शन, पैरेलल रूलर के दो एज हैं, इफ़ इट इज़ वर्टिकल इन फ्रंट ऑफ यू, एक राइट साइड में एज है, एक लेफ्ट साइड में एज है। सो जस्ट टू मेंटेन इट्स एक्यूरेसी, अगर आप राइट साइड का एज यूज़ कर रहे हो, ऑलवेज यूज़ द राइट साइड एज, ओके, इट विल गिव यू लिटिल मोर एक्यूरेसी। नॉट दैट लेफ्ट साइड का यूज़ करोगे तो क्वेश्चन गलत हो जाएगा, बट यू सी हर एक पैरेलल रूलर में थोड़ा सा प्ले होता है, सो दैट प्ले कुड बी डिफरेंट ऑन राइट साइड एंड लेफ्ट साइड, ओके। अगर आपको कहीं यूज़ करना हो आप लेफ्ट साइड भी यूज़ कर सकते हो, ऐसी कोई मनाही नहीं है बेटा, ओके। डिड यू अंडरस्टैंड बेटा?
यस सर
वेरी गुड। दीपक हैज़ ए पैरेलल रूलर। दीपक, यू आर
सर
लुकिंग
ये
ग्रेट।
वाला बोल रहे हो आप या ये वाला?
लंबा वाला बेटा, लंबा वाला एज यूज़ करते हैं हम।
ओके ओके सर, ठीक
सो
है।
अगर ऊपर वाला एज यूज़ कर रहे हो तो ऊपर वाला ही यूज़ करो, प्रेफर करो कि ऊपर वाला ही यूज़ करेंगे, दैट गिव्स यू लिटिल मोर एक्यूरेसी,
ओके सर।
ओके। लेट्स मूव
सर
अहेड।
ये जो लास्ट लास्ट वाला पॉइंट है,
हाँ बेटा,
अवॉइड यूजिंग ए कंपास और डिवाइडर फॉर दिस पर्पस।
राइट। बेटा आपने
सर
पेपर चार्ट पे कई बार देखा होगा कि पोजीशन प्लॉट करने के लिए लोग क्या करते हैं, डिवाइडर उठाते हैं। पेपर चार्ट की बात कर रहे हैं बेटा, फॉरगेट अबाउट एक्डिस। लोग
यस सर,
डिवाइडर या कंपास उठाते हैं और लैटिट्यूड को साइड से मैयर करके फिर चार्ट में उसकी मार्किंग कर देते हैं। देखा आपने कभी ऐसा
यस सर,
करते हुए? इस चीज़ को अवॉइड करना है हमने अपने पेपर में। प्रैक्टिकली इफ़ यू आर डूइंग दैट इट इज़ ओके, बट अवॉइड डूइंग दैट इन द पेपर, क्योंकि जब आप कंपास या डिवाइडर को यूज़ करते हो बेटा, उसका नट थोड़ा टाइट या लूज़ भी हो सकता है, एंड आप जब ये ट्रांसफ़र कर रहे हो तो वो हिल सकता है, गिविंग यू ए एरर इन योर वर्किंग।
ओके सर। तो उसके लिए क्या करना है सर फिर?
पैरेलल रूलर यूज़ करना है बेटा। जो भी लैटिट्यूड हमने मार्क करना है, हमें पैरेलल रूलर अलाइन करके उस लैटिट्यूड पे लेके जाना है।
ओके सर, ओके। पहला रूलर से ही होगा सर, वो तो अच्छे से प्लॉट।
यस, दैट इज़ राइट बेटा।
ओके, थैंक यू सर।
ओके, लेट्स प्रोसीड
सर
अहेड।
मैं बोल रहा था थोड़ा सा ना, हमारे बैच में ना सर,
हाँ बेटा।
थोड़ा सा ना सर आप हिंदी में बोल दीजिए सर, कि पूरा आप इंग्लिश बोलेंगे ना तो इनको तो हमको थोड़ा अच्छे से समझ में नहीं आता सर। तो
बेटा
थोड़ा थोड़ा सा ना
हाँ
हिंदी
हाँ,
में बोल दीजिए सर। ऐसे ऐसे ही करना है, ऐसे ऐसे आप जो भी समझा रहे हैं वो समझ में आ रहा है, ऐसा नहीं है सर। बट थोड़ा सा बोल दीजिए सर, ज्यादा बेटर हो जाएगा सर।
बेटा मैं तो हिंदी पंजाबी दोनों में बोल सकता हूँ, बट क्या है कि हमारा ऑफिशियल मोड ऑफ ट्रांसमिशन जो है ना वो इंग्लिश है, सो मैं इंग्लिश में बोलूँगा, बट आई विल यूज़ वेरी सिंपल इंग्लिश, ओके। और तुम्हें जहाँ भी दिक्कत होगी बेटा, उसी स्लाइड पे मैं जब पूछूंगा ना डाउट्स क्या हैं, तुमने वहीं मुझे रोक देना है, ओके बेटा।
ओके सर जी।
अभी तक ठीक ठाक है ना?
हाँ सर, अभी तक ठीक है सर।
बस बढ़िया बेटा, ठीक ही रहेगा।
For measuring of the latitude and longitudes, there is a tendency that if the compass and divider is too tight or too loose, so by the time you transfer it from the position to the latitude or longitude scale, the compass or divider may uh, uh, get disturbed and it may give you a wrong reading. Now, another very important thing for chart work is the use of proper symbols. Now, this is very, very important because when we make a plot on the chart, we are trying to communicate with the paper checker of what we have drawn on the chart. Usually the plot is not labeled. We do not write there that this is my course made good, this is my course steered, or this is the current. What we do is we use the symbols to denote all these quantities. So use of proper symbols is very, very important. So use appropriate symbols to indicate various parameters like the course steered, or CTS, which is course to steer, CMG, that is course made good, current, celestial position lines, transferred position lines, DR positions, estimated positions, and fixes. So let us see these symbols one by one now. So you can see the symbols on the right side of the screen. Let's go through these symbols one by one. So on top here, you see the symbols we used to mark a dead reckoning position or DR position. So that's a simple cross using a horizontal line and a vertical line along with the time mentioned. So this is the symbol we use for marking or plotting a dead reckoning position or DR position.
Go ahead, beta.
सर सॉरी टू डिस्टर्ब यू बट एक क्वेश्चन था सर, जो अब डेक रिकॉर्डिंग पोजीशन है सर, सो ये हमारी जो हॉरिजॉन्टल लाइन है सर, ये हमारा कोर्स है, और वर्टिकल लाइन है ये हम लोग मार्क करेंगे. अगर हम लोग एक्स की तरफ मार्क कर दें सर, थोड़ा लिटिल बिट चेंज होगा तो ये गलत तो नहीं हो जाएगा?
No beta, that is okay. You can mark the DR position as a X also. It is the second method beta.
Okay sir, thank you sir.
Okay, let's move ahead.
The next symbol which you see is the symbol for a estimated position, in short also known as EP, Eco Papa. So we mark off a triangle with a dot in it, and the time is also mentioned here. So this is the symbol used for EP, estimated position. The third symbol which we see here is the symbol used to plot a fix. So we have a circle with a dot in the center representing the position, and you have the time mentioned here for which this position was applicable. So this is the symbol for a fix or a known position. Now, if you want to mark the fix obtained from an electronic device, say for example GPS or GLONASS, then it is represented by marking off a square with a dot in the middle, along with the time for which this fix or position was applicable. Then the next symbol which you see is the symbol used for the course steered. So whatever course the vessel has steered, we denote that by marking off a single arrow. So you see this single arrow. Along with the single arrow, we also mention what is the course which the ship is steering. So you see here in this particular case, 095 degrees true. That's the course steered. The next symbol which we see here is the symbol for course made good. So to represent the course made good, we denote it by double arrows. So you see double arrows marked on the course. That denotes it is the course made good. Along with it, we also mention what is the value of the course made good. The next symbol which we see here is the symbol for current. Current is represented or marked using 3 arrows. So you see 3 arrows marked on the current vector. Along with it, we mention what is the set of the current, or what is the direction in which it is taking us. These 3 are very important in chart work. Almost 90% of the chart work questions, they involve the concept of course, speed and current vector triangle, and all these 3 symbols are very frequently used there. That is the course steered, the course made good, as well as the current. Now the next symbol which we see is the symbol for marking a position line. So a position line could be a bearing from a particular object, say for example a lighthouse, or it could be a celestial position line. So it is marked by putting a arrow at the end of the line. If it is a bearing, the arrow will be only on one edge or one side of the line. But if it is a celestial position line, in that case you will have the arrows on both the sides of the line. Now this arrow at the end of a position line or PL indicates or denotes that it is not necessary that the vessel's position will lie on this line segment only. The vessel's position can be anywhere on the line extended on the side of the arrow. So this arrow represents the vessel's position could be anywhere when we extend the line in this particular direction. Now the next symbol which we see here is a transferred position line. What is a transferred PL? Now many a times we need to transfer our position lines from one time to another time. Let's say a PL was taken at morning 9 o'clock and we need to transfer it to 10 o'clock. So when we transfer a PL, it is represented by marking of double arrows on both the ends of the position line. So these double arrows indicate that this PL was not taken at this time. It was taken at a different time, but it has been transferred here for our use. So this is the symbol for a transferred position line. Now beta, the use of proper symbols in chart work plotting is, as I told you earlier, very important. If you have not shown proper symbols in your plot, the plot will be very confusing. It will be very difficult for the paper checker to understand what you have plotted, and the penalty imposed by him in way of cutting marks is also severe in the case. So even if you have done the question right, but the symbols are not there, you can lose almost more than 50% of the marks allotted to the question. So whenever you practice the chart work question, always remember to plot the correct symbols so that you form a habit of using these symbols whenever you plot.
Sir, one question, sir.
Go ahead, beta.
Sir, if we write like CMG instead of this symbol, course made good, I write that CMG on the chart. Will it be considered right or wrong?
No, beta. You will have to make the symbol. Writing is usually avoided on the chart. Reason is कि अगर हम हर एक चीज़ को लिखना शुरू कर देंगे तो हमारा जो चार्ट का प्लॉट है वो बहुत कंजस्टेड हो जाता है. सो इसलिए हम लिखते नहीं हैं, हम उसे सिंबल से ही शो करते हैं.
थैंक यू।
ओके, और डाउट बताओ बेटा अभी तक।
Sir, is it right that while plotting course tiered, we use the reference of speed through water, and while course over ground, it is speed over ground?
दैट्स राइट बेटा। जो
Sir,
कोर्स
what
टियर
is the
होता है,
behind,
जो हाँ मैं
speed through
आपको
water?
डिटेल में बताऊंगा तीनों के बारे में, कोर्स टियर्ड, कोर्स मेड गुड और करंट। ये मैंने अभी आपको डिटेल में बताना है कि ये क्या होते हैं, पर जो आपने अभी बोला है दैट इज़ करेक्ट।
हाँ जी, just I wanted to know the reason behind that कि course to steer में why do we have that speed through water?
ओके, वी विल कम टू इट बेटा। जब हम ये ट्रायंगल बनाएंगे ना, कोर्स स्पीड एंड करंट वेक्टर ट्रायंगल, मैं ये चीज़ आपको एक्सप्लेन करूंगा। ओके, और डाउट बताओ बेटा।
सर टाइम को इसी तरीके से डिनोट करना है जैसे लिखा हुआ है 0830।
बेटा और कौन से तरीके से डिनोट कर सकते हैं?
सर जैसे कि पहले बताया था कि 08 ऐसे लिखना है और 30 जो है लाइक मिनट्स जो है वो ऊपर को लिखना है थोड़ा।
ओके, ऑल राइट बेटा।
और
आई
नीचे
वुड
एक डैश
रिकमेंड,
मार के डबल डॉट।
आई वुड रिकमेंड टू कीप इट सिंपल। ओके, वैसे भी लिखा जाता है, यू आर राइट, सम पीपल राइट लाइक दैट to denote the hours and minutes separately, but I would recommend that you guys keep it simple and write it in a simple language.
यस सर।
ओके, और डाउट बताओ बेटा। ओके, ग्रेट, लेट्स मूव अहेड।
Now, using wrong symbols or no symbols will result in a very confusing plot and certainly losing a lot of marks. As you have seen in the symbols, whenever we draw positions, whenever we mark or plot positions or position lines on the chart, it is always recommended to state the times when those positions or position lines were applicable. So as you see here, with every position, the time is marked. With a PL also, it is recommended to mark off the time when that PL was applicable or effective. Now let's go a little bit into what is the method or procedure to solve any chart work or terrestrial navigation question. Now, the first important thing which we have to do here is to read the question very carefully. So read the question very, very carefully and write down the given data on the answer sheet. You don't need to write down the positions of lights. It is also mentioned in the question, the latitude and longitude. So that is just given for identification purpose. Now, once you have noted down all the data on your answer sheet, double check that you have not made any mistake in noting down any of the item. Once you have all the necessary data for working out the problem, you can start solving it or start using your brain how to proceed ahead. Now, for finding out the solution of a chart work question, it is not like celestial navigation question where you know that a certain formula is to be used. Let us say if you are solving a long by Cron question.
Beta, have you done long by Cron in CellNav now or not yet?
Not yet, sir.
Not
Okay.
नहीं सर,
अभी नहीं हुआ सर।
ओके, प्रीसी का कुछ याद है बेटा?
नहीं सर।
हाँ थोड़ा होगा सर।
थोड़ा बहुत याद है सर।
ओके, नो प्रॉब्लम, ठीक है बेटा, ऑल राइट।
You know the formula, you pick up the data, apply it, and you get the answer. In chart work question, you have to find out what is the technique or method to be used in a particular question. So for that, it is very, very important to check what information is given, because the method which we use in chart work depends upon what all information is given to us. I will give you a simple example. Let's say they give you 3 bearings. In one question, all the 3 bearings are from a single object. If that is so, we use a different method. It is known as 3-point bearing or 3 bearing method. Now in the second case, they give you 3 bearings, but 2 of them are from a different object and the third one is from a different object. Now in this case, we will have to use a different method. So it is very, very important that we analyze the data carefully. What is provided, what information is provided to us. Now, once you have checked the data, then you can follow this short 1, 2, 3 method. Number 1 is understanding. So as I told you, you need to understand what data is provided. For understanding, it is very beneficial if you make a rough diagram. You can make this rough diagram on your answer sheet. It is not mandatory as far as the question solving is concerned, but this rough diagram helps you to understand how do we go ahead or what method do we use for solving a particular question. Because the data which is given to us in the question is in the text format. When you put it or convert it into a diagram format, it is very, very easy for the mind to understand that data. So making a rough diagram makes it very easy for us to find out what method we should be using here. So once the rough diagram is there and you know which method is to be used, so once that much clarity is obtained, you can go ahead and make your final plot on the chart. So remember, the question has to be solved in your mind first before you start solving it on the answer sheet. If you straight away try to jump on the chart, reading up the question from the question paper, trying to plot the required data on the chart straight away, you may get stuck in between and you may lose the track on which to proceed ahead.
Okay, so beta, let me know any doubt which you may have till now. I would recommend beta that you take a screenshot of this particular slide. So keep it safe on your device so that you can refer to it at a later stage also. The symbols are very, very important. So take a screenshot and keep it safe on your device. If you want, you can make these symbols noted down in your chart work notebook also in your notes.
Yes, sir.
सर विंड का कोई डायरेक्शन वो नहीं होता क्या सर सिंबल?
नहीं बेटा, हम लोग विंड को चार्ट वर्क में शो नहीं करते हैं. विंड का जो इफेक्ट होता है उसको हम लोग बोलते हैं लीवे, उसको हम अप्लाई करते हैं.
ओके सर. तो पता कैसे चलेगा सर विंड का कि अपने कैसे किधर से आ रहा है और किधर इफेक्ट कर रहा है?
ओके, विंड किधर से आ रहा है ये हमें क्वेश्चन में दिया होगा और विंड
जी डायरेक्शन तो दे दी सर.
राइट, और ये
तो
हमें कैसे इफेक्ट करता है वो हम सीखेंगे. अगली क्लास में मैं आपको विंड और करंट दोनों के बारे में बताऊंगा. तब आपको पता चलेगा कि हम विंड के इफेक्ट को कैसे कंसिडर करते हैं.
ओके सर। और उसी क्लास में सर वो पोजीशन लाइन वाला ही बता देना सर, जो डायरेक्ट जो मतलब उसके एज लास्ट एज पे जो एरो है ना सर, उसको कैसे, उसको बाद में एक्सप्लेन कर देना सर जब भी आप कराएंगे तब।
वो एरो कैसे ड्रॉ करते हैं या उसका मीनिंग क्या है?
नहीं सर, जैसे करंट कोर्स में गुड कोर्स स्टेट का तो समझ में आ
ओके
रहा है
ओके
सर,
ओके, हाँ हाँ।
लेकिन पोजीशन लाइन वाला ऐसे कि एक लाइन मार दी तो जहां जहां से हम बेयरिंग ले रहे हैं, जहां से भी उसको मेजर कर रहे हैं, तो उसके लास्ट एज पे मारना है या कैसे मारना है सर, उसको
ओके
शो
ओके
कैसे
बेटा,
करना
आई
है,
विल टेल
बस
यू,
वो वाला
डोंट वरी, आई विल टेल यू, डोंट वरी।
उसको थोड़ा ओके सर बता दें बात।
राइट, आई विल टेल यू बेटा।
Calculations which are required when you convert the data from the uh, text which is given in the question paper to what is required on the chart. Say for example, they could give you compass bearings of a particular object. Now for plotting on the chart, you need to convert them to true bearings. So before we start the plotting, we need to do many calculations like this. So all these calculations which you are doing, now sometimes in haste, especially in the exam conditions, people do these calculations on the calculator and straight away plot them on the chart. So the examiner may get confused, how did you reach to that conclusion? So all the calculations which you are doing, they should be shown on your answer sheet. So all calculations required for solving the problems should be shown in detail on the answer sheet. That is the formula, any formula which you are using, the values of each parameter, and the answer obtained. All this should be clearly mentioned on the answer sheet. Now, merely calculating the values by the calculator and writing the answer on your answer sheet or on the chart will not be sufficient. That leaves a lot of doubt in the mind of the paper checker, and it may result in losing of marks. Now, if some of the data is calculated by using the Norris table, so we may refer to Norris table, we may refer to deviation card, we may refer to luminous range diagram. So whatever data we obtain from any of them, please mention the name of the table, or you have got this data from the luminous range diagram on your answer sheet. Now, after you complete a particular question, erase all the extra or unnecessary lines or markings which you may have drawn on the chart during plotting. So all these lines, all these markings which are not relevant to the plot, they should be removed, they should be erased to avoid confusing the examiner.
Beta, all okay up to here? Any doubts? Okay.
So only keep the required item, the relevant items, which are part of the plot. Now let's move on to the concept of position line. We will understand what is a position line, and we will understand how the information regarding a position line is provided to us in chart work questions. A position line basically is a line on our chart on which the vessel's position lies. So if we have a PL, we know that the vessel's position will lie on that position line only. There are different methods with which position lines can be obtained. So we will now see what are the different methods with which PLs can be obtained and how the information about the position lines is provided to us. Okay, now let's go into different methods with which position lines may be provided to us. Now, one of the method by which position lines can be provided to us is by way of visual bearings. So visual bearings of an object can be obtained by using different instruments. You can get the bearing of a object using a gyro compass. Now, if a gyro compass bearing is given to us, we need to apply the gyro error. Gyro error will also be given to us in the question. We need to get the true bearing of the object for plotting on the chart. Now, whenever we plot on the chart, we always plot true bearings. We never plot compass bearings. Gyro compass or standard compass bearings are never plotted on the chart. Now, if a compass bearing is given to us, then to convert it to true bearing, we need to apply the compass error. Now, compass error is a combination of deviation, which is obtained from the deviation card for a particular compass course, and variation, which may be given in the question paper, or the variation may be picked up from the chart. It is mentioned in the question paper whether you have to use a particular variation value or you have to pick up the variation from the chart. I will tell you how variation is picked up from the chart. So once you apply this compass error to the compass bearing, we get the true bearing, which we can then plot on the chart. Now the third method which could be used to provide us a bearing is by way of a relative bearing. Now, a relative bearing is basically with reference to the ship's head. Compass bearings are given with reference to the compass north. A relative bearing is given with respect to the ship's head. So we need to apply the ship's heading to the relative bearing and get the true bearing for plotting on the chart.
Beta, just give me 1 minute. I'll be back. Okay, beta. So, beta, let me know if you have any doubts till now, up to here.
No, sir, no.
Sir, if we have the relative bearing, so we will apply our true course in order to get the true bearing from that.
Right, beta, that's right. If you have a relative bearing, you have to add the true course, or better than true course, you call it ship's head. So whatever direction the ship's head is pointing, you add that value to the relative bearing and when you add it, it gets converted to true bearing. Okay, I will show you a small video, a 5 minutes video on relative bearing just now. Once we finish the doubts, I'll show you the video. Okay, so shall we move ahead, beta?
Yes, sir.
Yes,
Very
sir.
good. Let's go. Let me show you a video. Let me set it up. Just give me a minute.
And this is a line of sight of object from the observer. So this angle is going to be true bearing of this lighthouse. Well, I can explain this that the true bearing of an object is the angle at the ship, that means that is observer, between the geographical north or true north and line of sight of object from the ship. So this is a 0, 0, 0 degree. This is a 0, 0, 0 degree, that is true north. This is 0, 9, 0 degree. This is 1, 8, 0 degree. This is 2, 7, 0 degree. And this is 3, 6, 0 degree, which is again 0, 0, 0 degree. So we can say that the bearings are measured from 0, 0, 0 to 3, 6, 0 degree, but in clockwise direction.
So beta, this is the concept of a true bearing. A true bearing is basically measured with reference from true north. You measure it in a clockwise direction, and it starts from 0, 0, 0 and it goes up to 3, 6, 0, where it becomes 0, 0, 0 again. So this is the concept of true bearing in 3-figure notation or true notation. So is this clear, beta, up to here? Any doubts? Okay, very good. Let's continue then.
Direction. So this is called clockwise motion. Now let us look again. This is true north, this is observer, this is the object, say lighthouse, and this is the line of sight. So we can say that this is true bearing. However, the ship's head is in this direction. So we can say that this angle is a relative bearing. The relative bearing is defined as this is an angle at the observer between the ship's head and line of sight of object from the ship. Relative bearing is measured clockwise from 0 degree to 360 degree, and this is measured from the ship's head. Well, the 0, 0, 0 degree is the ship's head, and that's the only difference from true bearing. So let's have a look here. Suppose this is a vessel and this direction is true north, and suppose this is an object. So this angle is going to be true bearing. Well, if this is the ship's head is in this direction. This is the fore and aft line. So this angle from the ship's head to the object, to the line of sight of the object, is called a relative bearing.
So is this clear, beta? Is the concept of relative bearing clear?
सर अगर जो ये लाइट हाउस हमारे पोर्ट बाउ पे होता तो हम इसको
Right.
क्लॉकवाइज मेजर करके ये 300 समथिंग होता हमारे लिए रिलेटिव बेयरिंग.
Right, beta, that's right. We measure it in the clockwise direction only. So even if it is on our port side, हम इसे clockwise ही measure करते हैं. The angle in that case would be close to 340, 350, that way.
Okay, sir.
Okay.
Is called a relative bearing. Now let's have a look here. Suppose this is ahead, this is Esther, and this is the object. So this angle is the relative bearing. I just change the configuration. This one is called starboard beam. This one is called port beam. Well, 45 degree to this. This is called starboard bow, and this is called port bow. Similarly, this is called starboard quarter, and this is called port quarter. So relative bearings are important as collision avoidance rules use reference of relative bearing. Basically, these relative bearings are the direction of other ship from on ship's head.
So beta, this is also clear. You see the directions. Starboard bow, starboard beam, port beam, starboard quarter, port quarter. So whenever directions are seen or referred to in chart work in relative bearing, whenever they tell you this is the lighthouse was on our starboard beam, they are giving us a relative bearing of 90 degrees. So whenever they refer the lighthouse was on a port beam, this is again a relative bearing, and port beam is at a relative bearing of 270 degrees. So beta, just now give me 1 minute. I had a network outage, so this technician has come. So you have a look at this diagram. I will just get it done. Give me a couple of minutes. Huh?
Okay.
Okay. Okay, beta, thanks for waiting. So that technician had come actually, and the problem is sorted out now. So let's continue. So these are the relative directions which are sometimes given to us in the chart work questions. They sometimes tell us a lighthouse is on the starboard beam. Sometimes they say lighthouse is on the port beam. So we should know how to find out the bearing of that lighthouse. So once we know this concept of relative bearing, it can be easily found. So let's proceed ahead now. Any doubt in your mind till now? Okay, great.
And this is called port quarter. So relative bearings are important as collision avoidance rules use reference of relative bearing. Basically, these relative bearings are the direction of other ship from on ship's head. Now let's talk about conversion of bearings. So relative bearing plus true course will give you true bearing. Let's take this example. Suppose relative bearing is 210 degree and the true course is 250 degree. Then true bearing is 210 plus 250, that is 460 degree. However, the bearing cannot be more than 360 degree. Bearings are measured from 0 to 360 degree. So we need to subtract this 360 degree. The bearing is 100 degree. Let me explain from this diagram. Well, this is the ship's head. So the true course is 250 degree. That is this angle from true north to the ship's head. That is 250 degree. Now the relative bearing is 210 degree. That means this angle is 210 degree. Well, the true bearing is going to be the sum of that 210 plus 250, that is 460. However, we need to subtract this 360 degree. So the true bearing is from here to here, which is 100 degree.
So did you understand this diagram, beta?
Yes, sir.
Okay, all right. So the basic principle is if you are given a relative bearing, you have to add the ship's head to it and then you will get the true bearing. And anytime the bearing goes greater than 360, so we have to subtract a 360 from it to bring it within the valid range. The bearings always lie between 000 and 360. अगर कभी भी ये 360 से बड़ी वैल्यू आ जाए तो आप उसमें से 360 सब्ट्रैक्ट कर सकते हो, और कभी भी अगर किसी कैलकुलेशन में आपकी बियरिंग नेगेटिव में चली जाए, माइनस में चली जाए, तो आप उसमें 360 डिग्री ऐड कर सकते हो टू गेट द करेक्ट बियरिंग. सो क्लियर टू एवरीवन बेटा?
Yes, sir.
Very good. Let's go back to the presentation now.
Let's now refresh the concept of compass error, which consists of variation and deviation. So we are going to first discuss about variation. Magnetic variation is the angle between magnetic north and true north, and it is caused by the different locations of the geographic north pole or the true north pole and the magnetic north pole. So you can see in this diagram, in the green color, we have the true north pole marked, and in the blue color, you have the magnetic north pole marked. Now you can see they are at different locations. The true north pole is basically the point from where the axis of the earth pass through the earth's surface. We know the earth is rotating on its axis from west to east. Now this axis passes from the surface of earth at 2 points. Now these 2 points are known as the geographic poles or the true poles. So the true north pole is marked in green color here. The magnetic north pole is decided by the magnetism of the earth or the magnetic properties of the earth. Just like every magnet has 2 poles, the red and the blue pole, similarly the earth also has magnetic properties, and it has magnetic north pole and magnetic south pole. Important thing to understand or know here is that these magnetic poles are not located at the same place where our geographic poles are or the true poles are. They are at a different location. Also, the location of magnetic poles is not permanent. It keeps on shifting. So variation, what we are talking about here, is the angle at any particular position on earth. It is the angle between the magnetic north pole and the true north pole. So you can see here in the diagram, this variation is shown here as an angle between these 2 poles, the magnetic north pole and the true north pole. Variation will differ from place to place. So as the ship changes its position, the variation also keeps on changing. You can visualize it here in the diagram. Now, as the position of the observer keeps on changing, the angle between the magnetic and geographic north pole will also keep on changing. Variation is not dependent on ship's head or the course. As you can see, the ship's head or the course which the vessel is steering has got no role to play in the variation. It is entirely dependent upon the position of the magnetic poles and the geographic poles. Now variation is provided to us in the question paper in 2 different ways. One, they could mention you what is the variation to be used for solving the questions. Let us say, for example, they will give you a value of 5 degrees east. So this is a standard value to be used when you are plotting any of the chart work questions on the chart. It is mentioned in the notes which are given in on top of the paper. So that is one way in which variation can be provided to you. It can be simply picked up and used irrespective of where the ship is, anywhere on the chart. Now, the second way in which it could be given is they could tell you to use the variation as mentioned in the chart. Now, if it is given in this way, then we will have to find out what is the variation at a particular place and then use that variation in our chart. So the next question which comes in our mind is how to pick up the variation from the chart. So variation value is mentioned in all the compass roses. You have the compass roses at different locations on the chart. So the variation in that area is mentioned in the compass rose. Now, as I told you that these magnetic poles keeps on changing their location. So year after year, the value of variation also keeps on changing. So how to represent this change in the chart? So let's see now, how do we pick up the variation from the chart and how do we account for this change?
Now, before I go into the video for picking up variation from the chart, any doubt up to here, beta, in this slide?
No sir, but I was asking variation sir, जैसे हम higher latitude पे आते हैं variation increase होगा sir?
Not necessary, beta. It can increase also, it can decrease also.
Okay.
Okay, it can vary in any way. I will give you an example. Let us see that from this position. I hope you can see the cursor.
Yes sir, yes sir.
So let us say from this particular position, the ship travels in a particular direction. Let's say the vessel moves like this, and the vessel comes here at this location. Now, if the vessel is where the cursor is right now, you see both the poles are in the same direction. Right?
Yes sir, the angle will be lesser.
So angle would be zero, almost zero at this particular location.
Yes.
Now let's assume a different scenario. Let's say from the starting position, the vessel goes to this location here, exactly middle of the two poles, midway of the two poles. Can you tell me what will be the variation here?
So 180.
Very good. It will be 180 degrees. So it can be very tricky when you go close to the poles. Variation can vary quite a bit. Even if when you move a small distance, the variation can vary a lot. So that is what happens when we go in higher latitudes. Okay. और कोई डाउट बेटा अभी तक?
No sir, no sir.
Okay, very good. बेटा इंग्लिश ठीक ठाक चल रही है? इंग्लिश इज ओके?
Yes sir, not an issue.
Okay, all right. कल बेटा इंग्लिश के बारे में किसने बोला था? आकाश तुमने बोला था बेटा?
No sir, मैंने था.
Who was there? आज इंग्लिश किधर है आज? Looks like he's not there.
वो मोर जितेंद्र ने बोला था.
जितेंद्र?
हाँ जी सर.
हाँ जितेंद्र भाई, इंग्लिश ठीक ठाक चल रही है?
बढ़िया सर एकदम.
ओके, वेरी गुड, ठीक है. ओके, सो लेट्स नाउ सी कि हम चार्ट से वेरिएशन को कैसे पिकअप करते हैं. सो आई विल शो यू ए स्मॉल वीडियो अगेन. उस वीडियो में हम देखेंगे कि चार्ट में कंपास रो से वेरिएशन को
Hi, welcome to this short video, an introduction to variation. So, what is variation? Well, we know that all vertical lines on the chart point to true north. But we also know the magnetic north is not at the North Pole. In fact, it's moving. The difference between them is called variation. So, how do we calculate variation? All charts have the information needed to calculate the appropriate variation for the area. From this, we can convert magnetic compass bearings to true chart bearings and vice versa. Essentially, we need to know two things. Firstly, what was the variation in a given year? And second, what was the annual change? Both these pieces of information can be found on the compass rows.
ओके, अब बेटा ध्यान से समझना है हमने इसको. अगर हमें वेरिएशन को फाइंड आउट करना है तो दो चीज़ों का पता होना चाहिए. एक तो ये पता होना चाहिए कि गिवन टाइम पे किसी भी टाइम पे किसी भी ईयर में उस जगह पे वेरिएशन कितनी थी। ओके, जैसे इस कंपास रोज में यहाँ पे इन्होंने हमें ये इन्फॉर्मेशन दी हुई है, इन्होंने इन्फॉर्मेशन दी है 7 डिग्री 20 मिनट वेस्ट, ये वेरिएशन थी और ये कब थी, दिस वाज इन ईयर 2005। सो अभी इसको मैं हाईलाइट भी करूँगा, इट विल बी जूम्ड। सो ये जो वेरिएशन थी इट वाज देयर इन 2005। एंड इसके साथ दूसरी चीज़ जो यहाँ पे लिखी हुई है ब्रैकेट में, वी विल जूम इट इन आफ्टर सम टाइम, दिस टेल्स अस कि भाई हर एक साल वेरिएशन में कितना चेंज हो रहा है। यही दो चीज़ें हमें चाहिए, एक पर्टिकुलर डेट पे या ईयर में वेरिएशन कितनी थी और हर एक साल में वेरिएशन में कितना चेंज हो रहा है। ये दो चीज़ें हमें चाहिए। अभी ये दो चीज़ें हम यहाँ कंपास रोज से पिकअप करेंगे। सो अप टू हियर क्लियर?
यस यस सर।
ओके, वेरी गुड।
How do we interpret the compass rose data? The two pieces of information are written along the arrow. In this example, magnetic variation was 7 degrees 20 minutes west in 2005. The part written in brackets tells us what the annual change to variation is. In this case, 8 minutes east. Using this information, we can see that it is 13 years since variation was 7 degrees 20 minutes west.
अब बेटा दिस वीडियो वाज मेड इन 2018, 2018 में ये वेरिएशन को कैलकुलेट कर रहे हैं। सो इन्होंने जो डिफरेंस निकाला है वो है 13 इयर्स। सो 2018 में दिस वीडियो वाज मेड एंड वेरिएशन जो हमें दी थी वो 2005 की वेरिएशन थी, तो डिफरेंस आ गया 13 साल का हमारे पास। अगर हम 2021 में इसकी वेरिएशन को निकालेंगे तो ये डिफरेंस 13 की जगह पे 16 साल का हो जाएगा। ओके बेटा, अंडरस्टूड?
यस सर।
यस सर।
वेरी गुड।
सर एक क्वेश्चन था सर, कैन आई आस्क?
हाँ बोलो बेटा।
सर ये जो एनुअल चेंज की वैल्यू होती है सर, ये कैसे पता चलती है सर कि कितना में हर जगह पे एनुअल चेंज डिफरेंट होता है, तो ये कैसे पता चलता है सर जो चार्ट पे मार्क होता है?
ओके बेटा, दिस इज डन, इसके दो मेथड होते हैं। 7 डिग्री 20 मिनट वेरिएशन मिली 2005 में एंड एवरी ईयर इट इज़ चेंजिंग बाय 8 मिनट्स ईस्ट, और अब हमें पता करना है कि 2018 में वेरिएशन कितनी होगी।
And has an annual movement of 8 minutes east. From this, we can work out that variation has changed by 104 minutes since 2005, i.e. 8 minutes times 13 years, which equals 104 minutes. We can convert this to whole degrees and minutes by dividing by 60, as there are 60 minutes in every degree. This comes to 1 degree and 44 minutes east. As the change since 2005 is east, in other words, opposite to the westerly variation, we need to deduct 1 degree 44 minutes from the 2005 variation to find out today's value.
ओके बेटा, सो क्या किया हमने, देखो 2005 में वेरिएशन थी 720, चेंज हो रहा था 8 मिनट ईस्ट। एक साल में चेंज होता है 8 मिनट्स का, तो हमने पता किया कि 13 साल में चेंज कितना होगा। सो 13 मल्टीप्लाइड बाय 8, हमें आंसर मिल गया 104 मिनट्स। सो वेरिएशन में जो चेंज आएगा वो आएगा 104 मिनट ईस्ट। अब अगर इसे डिग्री में कन्वर्ट करें तो ये बनता है 1 डिग्री 44 मिनट। तो वेरिएशन 1 डिग्री 44 मिनट ईस्ट इतना चेंज आएगा। अब हमारी शुरू की जो वेरिएशन थी वो वेस्ट थी, जो चेंज आ रहा है वो ईस्टर्ली है, इसका मतलब ये सब्ट्रैक्ट होगा। सो 720 वेस्ट में से 1 डिग्री 44 मिनट हम लोग सब्ट्रैक्ट कर देंगे और हमें 2018 की वेरिएशन मिल जाएगी।
variation to find out today's value. 7 degrees 20 minutes minus 1 degree 44 minutes equals 5 degrees 36 minutes west.
So this is the answer which we get, beta. 5 degree 36 minute west is the variation in 2018. So अब मुझे बताओ बेटा, इसमें कोई डाउट तो नहीं है किसी को?
सर
हाँ बोलो बेटा.
सर कंपास रोज पे वेरिएशन की जो वैल्यू है दैट होल्ड्स फॉर ऑल द एरिया दैट इज इन द चार्ट.
नहीं बेटा, चार्ट पे 2, 3, 4, 5 कंपास रोज हो सकते हैं. तो आप जहाँ पर भी हो, जहाँ पे भी आपके शिप की पोजीशन है, आपने ये चेक करना है कि सबसे नियरेस्ट वाला कंपास रोज कौन सा है और आपने वेरिएशन की वैल्यू उसी कंपास रोज से पिकअप करनी है.
ओके सर.
ओके. और बेटा और कोई डाउट? Okay, very good. Let's move ahead.
Now we know how.
Okay, all right. This is more or less done. So
magnetic meridian. But the ships which we are sailing on are made up of steel. They are not made up of wood. Now steel is a magnetic material. It can have magnetic properties and it has magnetism of its own. Now this ship's magnetism disturbs our compass, which is known as deviation. So ship's magnetism deviates the compass from the magnetic meridian, and this is called as deviation. You can see this diagram here on the right side of the screen. We have a boat here, a wooden boat, in which a metallic engine is fitted. Now this metallic engine has magnetism of its own. It is made up of mild steel, which has magnetic properties. So this magnet which you see, red and white color magnet, this represents the magnet of a compass. Because of the magnetism of the engine, our compass is deviated or disturbed from the magnetic north direction, and this disturbance is known as deviation. Another important thing which you can see in this diagram is, depending upon the heading of the ship, the location of the engine will change with respect to the compass needle. So the deviation also keeps on changing as the ship's head changes. The angle between the magnetic meridian and the compass needle is called deviation. The deviation varies in name as well as magnitude as the ship's head changes. Deviation could be easterly or westerly, depending upon what is the heading of the ship.
Beta, any doubt up to here?
No, sir.
Okay, very good. Let's go ahead.
The deviation is obtained from a deviation card. Deviation card is available to us on board a ship, and a deviation card is also provided to us during the exam. Let me show you a sample deviation card. You can see this deviation card on the screen. This is how it is provided in the exams. Now this particular card has actually 4 deviation cards in it. You can see card number 1, card number 2, card number 3 and card number 4. When you go through the notes in the question paper, the notes will tell you which particular deviation card is to be used for solving the questions. Say for example, a particular paper tells you, please use deviation card number 2. Then you can see we have highlighted the deviation card number 2. Then this is the card which is to be used for solving the questions. Now in the deviation card, you can see that the card is entered from ship's head by compass. We have to know what is the ship's head by compass. Using the value of ship's head, we can enter into the deviation card and pick up the value of deviation. The heading value ship's head by compass is usually given for courses for headings which are 10 degrees apart. You can see the value given for true north 000. After that we have the value of deviation given for 010, 020, 030 and so on up to 360, which again is 000. Now to find any deviation value for intermediate headings, if you want to find the deviation value for any intermediate headings, we need to interpolate the values from this card. Let me explain this to you using an example. Let's try to find out the deviation for ship's head 145 using card number 2. Now you can see in the deviation card, we have the deviation value given for ship's head 140. The value of deviation is 5 degrees west. And we have the value of deviation for ship's head 150, which is 3.0 degrees west. Let's note down these two values. So you can see for compass course or ship's head by compass 140, the deviation value is 5 degrees west. And for a compass course of 150, the value of deviation is 3 degrees west. Now, if we want to find out the deviation for ship's head 145 or for compass course 145, we need to interpolate. So when we interpolate between 140 and 150, we can easily find out the deviation. The 145 value is exactly midway between these two, 140 and 150. So it is very easy. The interpolation is very easy here. The value of the deviation will also be midway between 3.0 and 5.0. So deviation for 145 comes out to be 4 degrees west.
Beta, have a good look at the compass card, the deviation card, and let me know if you have any doubts anywhere.
सर फिर इंटरपोलेट तो हम किसी भी वैल्यू के लिए कर सकते हैं ना सर, जैसे 145.9 होता या 146 होता तो उसके लिए भी इंटरपोलेट करके जस्ट वैल्यू निकाल लेंगे.
Yes, beta, that's right. You can interpolate for any value which is required.
Okay.
और बेटा और कोई डाउट आ रहा है?
No sir.
वेरी गुड, क्लियर. बेटा मैंने बोला था ना, मैं हर एक स्लाइड के बाद आपसे डाउट पूछूंगा. सो हैव यू सीन नाउ आफ्टर एवरी स्लाइड आई आस्क यू डाउट्स?
यस सर, थैंक यू सर.
और मैंने ये भी बोला था कि मैं सिंपल इंग्लिश यूज करूंगा. सो इंग्लिश इज ओके?
यस सर, एब्सोल्युटली फाइन सर.
वेरी गुड, ग्रेट. ओके, चलो बेटा आगे चलते हैं अब. So we have seen.
Now once you have the variation and deviation available to you, you can quickly find out the compass error. the resultant of variation and deviation is called the compass error. If both of them are of the same name, they are added up. If both of them are of different names, we subtract the smaller one from the bigger one and keep the name of the bigger one. So this is how we obtain the compass error. Now let's quickly refresh the procedure for converting compass to true and true to compass. Now, if you have a compass course given to you and you want to find out the true course, or you have a compass bearing and you want to obtain a true bearing, the method what we use is we start off with the compass course. We first apply the deviation, which is obtained from the deviation card. Now, what do I mean by apply? Deviation could either be added or subtracted. How to find out whether deviation is to be added or subtracted? Remember this idiom: deviation west, compass best; deviation east, compass least. So if deviation is westerly, compass has to be best. Best means bigger. Now if the compass course is bigger, the magnetic course will be smaller. So obviously deviation has to be subtracted. If the deviation is east, the compass is least. Least means compass course is smaller. Now if the compass course is smaller, that means the deviation has to be added to obtain the magnetic course. Once we apply the deviation, we obtain the magnetic course or magnetic heading. Now the second correction which we apply is the variation. So again, whether to add or subtract the variation, you remember the idiom: variation west, magnetic best; variation east, magnetic least. So variation is added or subtracted using this, and then you obtain the true course or the true bearing of an object.
Sir, can you sorry sir,
बोलो बेटा बोलो.
मैग्नेटिक के लिए आपने क्या बोला था सर? कि जब डेविएशन आ जाएगा तो उसके बाद मैग्नेटिक के लिए आपने कुछ बोला था सर, वो सुन नहीं पाया.
नहीं बेटा, सब कुछ यहाँ लिखा हुआ है. आपने डेविएशन निकाल ली. डेविएशन वेस्ट, कंपस बेस्ट; डेविएशन ईस्ट, कंपस लीस्ट. ये हमने याद रखना है, और डेविएशन को ऐड या सब्ट्रैक्ट करके हमें मैग्नेटिक कोर्स मिल जाएगा.
बट सर ऐड कब करना है, मैग्नेटिक को सब्ट्रैक्ट कब करना है, वो बता दीजिए इसके ऊपर.
ये अब देखो बेटा, डेविएशन वेस्ट में क्या लिखा हुआ है आगे?
कंपस बेस्ट सर.
वेरी गुड. अब अगर कंपस बेस्ट है, मतलब कंपस बड़ा है, तो मैग्नेटिक छोटा होगा.
हाँ सर.
अगर मैग्नेटिक को छोटा बनाना है कंपस से, तो डेविएशन माइनस करेंगे या प्लस?
सर माइनस करेंगे, छोटा बनाना है तो.
वेरी गुड, माइनस करेंगे. अब अगर डेविएशन ईस्ट है, तो हमने कंपस क्या लिखा है?
लीस्ट सर.
कंपस लीस्ट है. अब कंपस अगर लीस्ट रखना है और मैग्नेटिक को बड़ा करना है, तो डेविएशन को प्लस करना पड़ेगा या माइनस?
प्लस.
वेरी गुड बेटा, यू लर्नड. ओके. और बेटा, और बताओ बेटा, और कोई डाउट इसमें?
सर लास्ट स्लाइड में जो आपने कंपस एरर बताया था ना, तो जैसे कि इफ बोथ आर सेम नेम,
राइट.
सर अगर उसमें कंपस एरर मतलब जैसे मेरा कहने का मतलब ये था सर कि वेरिएशन डेविएशन है ना सर, जैसे कंपस एरर दे रखा हो और वो निकालने हो, तो उसके लिए कुछ अलग है क्या?
नहीं बेटा, बड़ा सिंपल है, बड़ा सिंपल है. अभी करके दिखाते हैं तुम्हें. इफ यू हैव डाउट वी कैन सॉल्व इट.
ओके सर, थैंक यू सर.
है ना?
ओके सर.
just give me 1 minute. बट एक तरीका आपको बता देता हूँ, कैडबरीज डेयरी मिल्क वेरी टेस्टी। सो CDMVT, इसे आप अगर याद रखोगे then you will remember the sequence in which deviation and variation are applied. Okay, Cadbury's dairy milk very tasty. So just remember it. हो सकता है कोई और भी तरीके से आपको ये याद हो, अगर वैसे याद है तो आप वैसे भी याद रख सकते हो। इम्पॉर्टेंट चीज़ ये है कि आपने इसे भूलना नहीं है, ये इम्पॉर्टेंट है, क्योंकि अगर हमने इसमें गलती कर दी तो हमारे जो क्वेश्चन हैं वो गलत हो जाएंगे। सो आगे चलें बेटा।
यस सर।
ओके,
from true to compass. We have just now seen how to convert compass course or compass heading to true courses or true heading. Now we will see how to convert from true to compass. We follow the same procedure but in reverse. We start off with the true course or true bearing, then go backwards. So to the true course or true bearing, we first apply the variation using the same idiom: variation west, magnetic best; variation east, magnetic least. So variation is applied to the true course, that means either added or subtracted, and we obtain the magnetic course. Now to the magnetic course, we apply the deviation using the same idiom: deviation west, compass best; deviation east, compass least. Now once we apply the deviation, we get the compass course or compass heading.
So this is also clear beta, any doubts?
नो सर, जस्ट रिवर्स जाना है ना इसमें बस।
बस बेटा रिवर्स जाना है
सर। और ये तो थ्योरेटिकली तो है सर, बाकी जब प्रैक्टिकली करेंगे तो और ज्यादा अच्छे से समझ में आ जाएगा।
राइट बेटा, राइट। सो अब इसमें एक दिक्कत आएगी बेटा, जब आप ट्रू टू कंपास कन्वर्जन करोगे, वन प्रॉब्लम विच यू आर गोइंग टू फेस, लेट मी टेल यू।
Yes, sir.
Now there is one issue which we are going to face here, and that issue is how to get the deviation. What is the problem in obtaining deviation here? The problem is deviation is given to us in the deviation card, and the deviation in this deviation card is mentioned against the compass course. Now when we are going from true to compass, this compass course is not known to us. We don't know what is the compass course. So what we know is the magnetic course.
So did you understand the problem beta?
Yes sir, yes sir, because magnetic course के बाद तो फिर हमको पता ही नहीं है आगे तो।
राइट, सो प्रॉब्लम ये है कि हमारे पास अभी मैग्नेटिक कोर्स है, कंपास कोर्स तो नहीं है, पर डेविएशन निकालने के लिए तो हमें कंपास कोर्स चाहिए। सो लेट अस सी कि हम इसे कैसे निकालेंगे।
Yes sir.
Now in the deviation curve or deviation card, the deviation is not given against magnetic course. So how to obtain the deviation when we do not have the compass course? So let's see it. Let's understand it using an example. Let's say we want to find out the deviation for a magnetic course of 153. Let me open up the deviation card for you. You can see the deviation card here. I have only kept deviation card number 2 So this is what we will be using for this example.
Jitendra, beta, you can mute your mic.
Now, first of all, you see in this deviation card, the deviation is given and the other course which we have is 160. So let's pick up the deviation for 150 and 160 compass courses. So you can see it here, the compass course and deviation. For compass course of 150, the deviation is given as 3.0 degrees west. So compass course 150, deviation is given as 3.0 degrees west. For 160,
1 degree west.
for 160, the deviation is 1.0 degrees west. So we noted down the deviation for 150 as well as 160. Now for compass course 150, I have the deviation 3 degrees west. If I have the compass course as well as the deviation, I can calculate the magnetic course also. So using these two, the magnetic course comes to be 147. You see error west, compass best. So if the compass has to be best or greater, the magnetic course has to be smaller. It should be 147. Similarly, for a compass course of 160, deviation is 1 degree west. Deviation west, compass best. So the magnetic course in this case would be 159. So you see, we were able to calculate or get the values of magnetic courses from the data given in the deviation card. Now what we will do is, we can now interpolate for deviation between the magnetic courses. You see, the magnetic courses are 147 and 159. And we have the value of deviation for both of them. So exactly as we were interpolating the deviation for intermediate courses using ship's head by compass, similarly, we will now find out the deviation by interpolation between magnetic courses of 147 and 159. Now the deviation what we require is for magnetic course 153. So 147 and 149, the value which we require 153 exactly falls midway between these two. So the deviation for this would be exactly midway between 1 and 3, that is 2.0 degrees west. So you can interpolate and the value of deviation comes out to be 2 degrees west. So this is how we can obtain the deviation if we have the magnetic course available to us and compass course is not there.
So have a good look at it, beta, and let me know if any doubts come to your mind.
सर जब अपन ने मैग्नेटिक कोर्स निकाल लिया सर डेविएशन यूज करके, तो फिर उसके बाद सर इसका जो सम करके डिवाइड बाय 2 आ रहा है वो 153 आ रहा है.
ओके,
मैग्नेटिक कोर्स का सर. तो यहाँ पे ये दोनों जो वेस्ट वेस्ट हैं जो दोनों जुड़ जाएंगे सर, डिवाइड बाय 2 हो जाएगा.
हाँ बेटा, सिंपल इंटरपोलेशन है.
लेकिन अगर यहाँ पे सर वो ईस्ट होता है एक.
ओके ओके ओके.
सर एक बार इसको फिर से एक्सप्लेन कर देना, थोड़ा नेटवर्क चला गया था.
ओके बेटा, कहाँ से नेटवर्क चला गया तुम्हारा? Did you listen to any steps?
यस सर, ये हो गया था नीचे जो अपने मैग्नेटिक कोर्स निकाल रहे थे ना 159 यहाँ से सर।
ओके, देखो बेटा, मैग्नेटिक कोर्सेज जब हमारे पास आ गए, नाउ इट बिकम्स वेरी सिंपल. वी हैव मैग्नेटिक कोर्स 147, डेविएशन फॉर इट इज 3 डिग्री वेस्ट. वी हैव मैग्नेटिक कोर्स 159, डेविएशन इज 1 डिग्री वेस्ट. हमें जो डेविएशन चाहिए वो मैग्नेटिक कोर्स 153 के लिए चाहिए. So we just interpolate between these two and get the deviation. Okay?
ओके सर।
Okay. अब बेटा एक और डाउट आ रहा है कि अगर इन दोनों में से कोई भी एक वैल्यू ईस्ट में आ जाती है तो क्या करेंगे. So let me show you on a whiteboard. Let us take an example. Let us say हमारी यही वैल्यूज हैं एंड इनमें से कोई भी एक वैल्यू ईस्ट में लेना चाहते हो बेटा. बताओ कौन सी वैल्यू लेना चाहते हो.
हाँ, कोई भी सर ले लीजिए, 1 ले लीजिए, 3 ले लीजिए।
सो हमारे मैग्नेटिक कोर्स हैं 147 एंड 159. हमें जो अपनी वैल्यू निकालनी है वो चाहिए 153 के लिए.
यस सर।
दिस इज व्हाट वी वांट टू फाइंड आउट. सो डेविएशन जो है, लेट्स टेक द डेविएशन एज पर योर चॉइस. What deviation you want to take for 147 बेटा?
सर 3 डिग्री ईस्ट.
ओके, सो ये हमने वैल्यू ले ली 3 डिग्री ईस्ट. एंड फॉर 159?
1 डिग्री वेस्ट.
1 डिग्री वेस्ट. सो अब हम इंटरपोलेशन कैसे करेंगे 153 के लिए. देखो बेटा, जब हम ये इंटरपोलेशन करते हैं, फर्स्ट लेट अस सी कि 159 और 147 इनके बीच में कितना डिफरेंस है. व्हाट इज द डिफरेंस बिटवीन दीज टू?
सर 12.
वेरी गुड. सो 12 डिग्री हेडिंग में जो डिफरेंस होता है, तो हमारी डेविएशन में कितना चेंज आता है. What is the change in our deviation? 1 डिग्री वेस्ट से 3 डिग्री ईस्ट तक टोटल चेंज कितना आया बेटा?
4 डिग्री सर.
वेरी गुड. डेविएशन में चेंज आया 4 डिग्रीज. 4 डिग्री का चेंज आया डेविएशन में. राइट बेटा? ओके, अप टू हियर?
यस सर.
वेरी गुड. अब बेटा 12 डिग्री चेंज के लिए हमारी डेविएशन में चेंज आया 4 डिग्री. अगर हमारी हेडिंग में 1 डिग्री की चेंज होती तो डेविएशन में कितना चेंज आता? डेविएशन में चेंज आता 4/12. करेक्ट बेटा?
यस सर.
अब हमें जो डिफरेंस चाहिए, हमारे कोर्स है 153. आप किसी भी वैल्यू से डिफरेंस ले सकते हो. इसका किससे लेना चाहते हो, 147 से या 159 से?
सर 1447 से.
ओके, सो हमने देखा कि 147 में और हमारी वाली जो वैल्यू है, इसमें कितने डिग्री का डिफरेंस है?
6 का सर.
6 डिग्री का डिफरेंस है. तो हमें 6 डिग्री डिफरेंस यहाँ पे चाहिए. तो 6 डिग्री डिफरेंस के लिए अब क्या करेंगे, ये जो 4/12 की वैल्यू आई थी, ये मल्टीप्लाई हो जाएगा बाय 6. जब आप इसका आंसर निकालोगे तो ये आएगा 2 डिग्रीज.
लेकिन डायरेक्शन.
हाँ, ये जो 2 डिग्री है बेटा, दिस इज द डिफरेंस इन डेविएशन. सो 147 की डेविएशन थी 3 डिग्री ईस्ट. 2 डिग्री का डिफरेंस आएगा. सो 3 डिग्री ईस्ट से जब 2 डिग्री का डिफरेंस आएगा तो वैल्यू कितनी बच जाएगी? 3 डिग्री ईस्ट माइनस 2 डिग्री. द वैल्यू ऑफ डेविएशन विल बी 1 डिग्री ईस्ट फॉर दिस पर्टिकुलर कोर्स.
सर 153 की जगह 152 होता तो 147 या 159 कहीं से भी ले सकते थे क्या?
कहीं से भी ले सकते हैं बेटा. बस एक चीज़ का ध्यान रखना है कि जहाँ से आपने हेडिंग का डिफरेंस लिया है, डेविएशन का डिफरेंस भी उसी वैल्यू से आएगा. इसका ध्यान रखना है. ओके बेटा, अंडरस्टूड?
सर एक क्वेश्चन था.
बेटा पहले इसमें समझ आ गया ये?
ये सर.
सर इसमें ना लास्ट बोल रही है सर, ये जैसे 2 डिग्री आया सर, तो
हाँ
उसकी डायरेक्शन क्या होगी सर, ईस्ट या वेस्ट?
अभी बताता हूँ मैं बेटा, 2 डिग्री डिफरेंस आ गया ना,
हाँ डिफरेंस 2 डिग्री आ गया सर 6 पे।
मतलब हमें अब 3 डिग्री ईस्ट से 2 डिग्री आगे जाना है। अब वो 2 डिग्री इसमें ऐड करें या सब्ट्रैक्ट करें, क्या करें, ये आपको दूसरी वाली वैल्यू बताएगी। जब आप 3 डिग्री ईस्ट से 1 डिग्री वेस्ट की तरफ चलोगे तो ये डेविएशन कम होगी या ज़्यादा होगी?
सब्ट्रैक्ट करना पड़ेगा सर, कम होगी सर।
वेरी गुड, क्योंकि जो भी वैल्यू आपकी आनी है वो इन दोनों के बीच में ही आनी है ना बेटा।
यस सर।
तो आपने ये देखना है कि इन दोनों के बीच में ऐड करके वैल्यू आ रही है या सब्ट्रैक्ट करके, आपने वही कर देना है।
ओके सर, थैंक यू सर।
ओके
डायरेक्शन जो ग्रेटर होगा उससे आएगी सर।
बेटा फिर से पूछो।
जो डायरेक्शन है सर, ईस्ट या वेस्ट?
बेटा जब आप 3 डिग्री ईस्ट में 2 डिग्री सब्ट्रैक्ट करोगे
ईस्ट
तो
में रहेगा।
ये 1 डिग्री ईस्ट ही रहेगा।
यस सर, ओके सर।
ओके
ओके सर।
ओके, अब बेटा नेक्स्ट डाउट बताओ मुझे। और भी किसी का डाउट था बेटा? क्लियर हो गया?
यस सर।
ओके बेटा, ऑल राइट। ओके, सो हमने बेटा अब डेविएशन निकालना सीख लिया है। कार्ड से डेविएशन को कैसे निकालना है ये हमें पता चल गया है। और अब हमने ये भी सीख लिया है कि अगर हमें ट्रू टू कंपस या कंपस टू ट्रू कन्वर्जन करना हो तो हम कैसे करेंगे। CDMVT टेक्निक हमें पता चल गई है, कैडबरीज डेयरी मिल्क वेरी टेस्टी। सो इसको यूज़ करके हम कंपस टू ट्रू और ट्रू टू कंपस अपने कोर्सेज को, अपनी हेडिंग्स को चेंज कर सकते हैं, बियरिंग्स को चेंज कर सकते हैं